Okay, the next one we are going to do is going to be question 2, and we're going to do part D. Yep, just doing one part of each question. Okay, so here we need to convert the following numbers. So we need to convert to 8-bit binary four bits after the binary point. Okay, so we are going, so this is our number 3.4375 and this, what we're doing is we're going from denary, it's actually fractional denary, to fractional binary. Okay, that's what we're doing. Okay, so we're going to do this. Okay, so the method here is to break out the break out the integer part and the fractional part. So we know what 3 is going to be in binary, I'll put that in full. So our column headings are 1, 2, 4, and 3 in binary is going to be 1, 1. So that is our integer part. We deal with that separately. Okay, now we're going to look at the fractional part. So we need to, and that was the first step. Now we need to, for my methods, I think notation is a really important part. If you think about long multiplication, long division, etc., the notation means the way you lay it out is part of the method. So that's what we're doing here. So 0.375. Now what we're going to do is we're going to take away the column headings of the fractional binary. So what are they? After the decimal point, they're 0.5, 0.25, 0.125, and 0.0625. And you should learn them. Those are obviously the same as a half, 1/4, 1/8, and 1/16. Okay, right. So, so the first thing we're going to do is we're going to take away, or attempt to take away 0.5. Can we do that? No, we can't do that. But what we're left with, because we couldn't take anything off it, is the whole amount, 0.4375. Now, because we couldn't take anything off, we have a 0 there. Okay, and then we copy this over, 0.4375, and then we're going to take our next column, binary column away. And we can actually do this, and so with the aid of a calculator, that is 0.1875. Is actually, I'm just going to change my layout. So we can do that. So we're going to have a 1 here. And what's left over when you do this subtraction is 0.1875. Now if you notice, this goes over here. So we do the same thing again, copying that over here. So now we're doing 0.1875, and then we've done this one, we've done this one, now we're doing subtraction of 0.125, the next column heading. So some people may have used this method for converting denary numbers to binary So we're just using it here for the fractional parts. Okay, so we can do this. So we're going to have a 1 here, and that subtraction gives us 0.625. Okay, and then we just copy that over here again, 0.0625, and then we've done that one, and now our last one is 0.0625, and that's going to be yes, because there's nothing left over, and so we're going to have a 1 here, and that's 0. So we don't need to go any further. So that means, now this is our most significant bit, and this is our least significant bit. So this fractional part we can bring together. So our 3 is 1, 1, and our fractional binary part is 0, 1, 1, 1. And let's just check. Convert to 8-bit binary number with 4 bits after the decimal, after the binary point. That's supposed to be binary point. So this is 4 bits after the binary point. And then that means that we need to pad this out. So we've got 4 here, 1 nibble, and then a 0, 0. So that's our final answer. Now remember, in our final answer we don't show the binary point, but I'm leaving it where it is just to show you can see that. Okay, good.